Hello guys, I'm Karthik SP from SPC 4th SIP. Today I'm gonna video present DAA design analysis of algorithm. Uh, I'm gonna tell a few question bank related key answers. So let's start. Discuss a sequence of steps in designing and analyzing an algorithm. So, basic steps involved in designing and analyzing an algorithm. So, the first step is to obtain a description of the problem. This step is much more difficult than it appears. Second, step two is the analysis of the program. Step three is develop a high level algorithm. Step four is refine the algorithm by adding more details. Step five is review the algorithm. The next question is, what is an algorithm? Discuss criteria of an algorithm. Define space as well as time complexity. So, algorithm. An algorithm is a step-by-step procedure to solve a problem in finite number of steps. Branching and repetition are included in the steps of an algorithm. The branching and repetition depends upon the problem for which algorithm is developed. Pseudocode and flowchart are popular ways to represent an algorithm. An algorithm must satisfy these following conditions: pause as well as unmean. Branching and repetition depends on the problem of which algorithm is developed. So, criteria for that is it is mainly divided in five parts. One is input, and another is output. Third is definites, and fourth is finiteness. Fifth is effectiveness. So, an algorithm should have zero or more, but should have finite number of inputs. So, in output, you have an algorithm must give at least one required result from the given set of input values. Defined as each step must be clear and unambiguous and precisely defined. Finiteness means algorithm should have been terminated after a finite number of steps. Effectiveness, each step of the algorithm must be feasible, practically possible to be perform the action, generally expected to be effective. So in that the subpart is time as well as space complexity. So what is time complexity? Is defined in terms of how many times it is taken to run a given algorithm based on the length of the input. Time complexity is not a measurement of how much time it takes to execute a particular algorithm, because such factors are program languaging, OS, and processing powers are to be considered. Um, Space complexity is an algorithm which is used to run on a computer. Its necessity is a certain amount of memory space. Amount of memory used by a program to execute is represented by its space complexity. The space complexity is auxiliary and input spaces. The third question is explain all asymptotic notations bigo, big omega, big theta, which are used to compare order of growth of an algorithms. Bigo is defined as an upper bound and of an algorithm is the most amount of time required. Bigo is used to describe asymptotic upper bound as well. So mathematically we can write it as 0 is less than equals to f of n less than equals to cg of n for all n is greater than equals to n. You can call this as a mathematical expression of Bigo, where n is defined as used to give upper bounds on an function, automatically 0 as well. Mm, sorry, O. Graphic examples of Bigo. See example of big theta as well. Big omega notations is defined as a lower bound and lower bound, and an algorithm is the least amount of time required. Just like O notations provided as asymptotic upper, theta omega notations provides asymptotic lower bound. F of n defined running time on an algorithm. So the mathematical expression of big O notation is 0 is less than equals to Cg of n less than equals to f of n for all n greater than equals to n naught, where n stands for used to give lower bounds as a function. Is a function of omega is automatically function as well. Graphical example of big omega. Big theta is defined as the tightest bond, and the tightest bond is the best of the worst case times, where f of n is defined as a running time of an algorithm. Mathematically, we can write as 0 is less than equals to c2 of g of n and less than equals to f of n, and n is greater than equals to n naught. Merging the both, we get 0 is lesser than equals to c2 of gn less than equals to f of n, less than equals to c1 of gn for all n is greater than equals to n naught. Equation must means that there exist few possible constants such as c1 as well as c2. The fourth question is explain the general plan for analyzing the efficiency of a recursive algorithm. Write an algorithm such as factorial for a given number. Analyze its efficiency. So first is we'll discuss about the general plan for analyzing the time efficiency of recursive algorithm. Step one is decide on a parameter indicating an input size. Step two is identify the algorithm basic operations. Third one is check whether the number of steps in the basic operation is executed can vary on different inputs on the same size. The fourth one is set up a recursive relations with an appropriate initial condition for the basic number of times. Fifth one is solve the recurrence of at least as certain as the order of growth of its solution. So in recursive evaluation, we have some mathematical expression f of n equals to f of n minus 1 star of n, where n is greater than equals to 1 and f of 0 equals to 1. Algorithm for it is we can write like m of n equals to m of n minus 1 plus 1 for all n is greater than equals to 0 to compute f of n minus 1 as well as f of n minus 1 by n. M of n minus 1 equals to m of n minus 2 plus 2 plus 1. M of n minus 2 equals to m of n minus 3 plus 1. So m of n we can write as m of n minus 2 plus 1 plus 1, m of n minus 2 plus 2, as well as m of n minus 3 plus 1 plus 2, m of n minus 3 plus 3, m of n minus 1 plus n. So finally we get as n. Overall time complexity is equals to O of n. And the fifth part is design an algorithm for checking all elements in an array which are distinct or not, derive its worst complexity. There is a program in it which starts like hash include less than bits bar stdc double plus of dot h greater than sign. You use namespace std. Bools are distinct for vector less than int of array. Int of n equals to array dot size, uh, closed braces and semicolon. Unordered set of int of s for all int I equals to 0, I is less than equals to n, I plus plus s dot insert of array I. Driver's code is int main std of vector int of array 1 2 3 are distinct. Cout all elements are distinct, close the braces. Else cout not all the elements are distinct, return of 0. Fifth question is design an algorithm to search all elements in an array using sequential search analysis. Derive its best case, average case. Case efficiency of an algorithm should be discussed. So linearly we can write it as int of search int of array int n comma int x. Int of I for I equals to 0, I is less than n, I plus plus. Array of I is equals to x, return of I, return of minus 1. Driver's code we can write it as int of main array of 1 comma 10 comma 30 or 50. Take int x equals to 30, int of n equals size of array. Print percentage of d is percent at index of percentage comma x. Search of array comma n comma x. Get char of return 0. Close the braces. End of the program. The sixth question is discuss brute force string matching algorithm. Illustrate with an example. Brute force is applicable for a wide variety of programs. For some programs, does not generate reasonable algorithms. If the program is not infrequently solved with the expense of developing a better algorithm, is not justified. Brute force algorithm must be good for small problem size. Brute force can be used for comparison of more sophisticated algorithms. Brute force sorting, selection sort, its algorithm for I is less than 0 for n minus 2 to 2. Min of I is equals to I, j equals to I plus 1 for n minus 1 to 2. A of j is less than A of min, then min is equals to j. Swap of A of j, A of I, and sorry, A of j and A of min. The another one is design an algorithm search an element in an array using sequential search. Derive its best worst as well as average. Algorithm for it is an array of size n for a target of element 2. Index of an target element is found or of minus 1. I equals to 0 to n minus 1, a of I equals to x, return of I. If the loop completes without finding the target element, searches for the target element by iterating through each element in the array. For I equals to 0 to n minus 1, if a of I equals to x, return of I. If the loop completes without finding the target element, return of n minus 1. The above algorithm sequentially searches for the target element by iterating through each element in an array. If the target element is found, the algorithm returns the index at which it is found. If return of minus 1 to indicate that the element is not present in an array. So let's discuss best average as well as first. Best case efficiency, best case scenario occurs with a target element found at the first index of an array, such as a of 0 equals x. In this case, the algorithm performs only one comparison and returns the index. Best case time complexity is like 0 of 1, since the algorithm terminates after a single comparison. Worst case scenario occurs when the target element is either not present in an array, is located at the last index of an array. Worst case, the algorithm performs n comparison with n is the size of an array. If the target element is found, the algorithm iterates through the entire array without finding a match. So the average case is in the average case, the efficiency depends upon the distribution on the target element within the array. On average case, the element would need to be searched half of the array elements before finding the target element on determining its absence. So the best case efficiency of the sequential search algorithm 0 of 1, O of 1 when the target element is found at the first index. So this completes best average as well as worst of it. The seventh one is design an algorithm for arranging numbers in ascending order. Selection sort with an example of its worst complexity. And another is seventh question is brute force string matching algorithm. So brute force string matching algorithm is a simple straightforward technique which is used to find the occurrence of a pattern string with a larger text string. Starts with a text string and a pattern string. Iterate through each character in the text string starting from the leftmost position. For each position, compare the characters of the pattern string with the corresponding characters in the text string. If a mismatch is found at any position, move to the next position in the string and repeat the comparisons. Disadvantage of divide and conquer. The eighth one is write the control abstractions of divide as well as conquer technique. List the advantages as well as disadvantages. So, what is control abstractions for divide and conquer? Uh, it can be summarized as follows. Divide the problem is divided into smaller subproblems of the same type or nature. Subproblems are solved recursively, typically by applying the same divide and conquer technique. Combine the solutions in the subproblem are combined to form a solution for the original problem. So the advantage part is efficiency, scalability, modularity, as well as problem flexibility. So in efficiency, divide and conquer algorithm has efficient time complexity by breaking down a problem into smaller subproblems, can reduce the overall computation times. Scalability, divide and conquer can be parallelized easily, taking advantage of the multiple process are distributed computing systems, leading to more scalability. Modularity for divide and conquer approach promotes modularity, breaking down a problem into smaller subproblems, can be solved independently and can then combined allowing for a easier code organization and maintenance. Divide and core approach is versatile and can be applied to a wide range of problems. Provides a structured methodology for solving complex problems by breaking down them into smaller, manageable parts. Disadvantage of divide and conquer is overhead divide and conquer approach. Nature of the algorithm, recursive functions for merging bar combining steps may be result in additional computations. So yeah, that is the end of this slide. Thank you. Have a nice day.